Good morning, guys. I hope you're all having lovely morning and enjoying the conference so far. Yeah, my titles for the talk is What's Next for DeFi and Account Abstraction, EIP-8141. This is the EIP that is considered as the headliner for the next hard fork for Ethereum. It's a bit technical, but it unlocks many new things for DeFi and particularly account abstraction. I'll keep it fairly simple and fast. Yeah, let's go. Three gaps we have in Ethereum today is post-quantum. Today we rely on ECDSA, which is a cryptographic algorithm, but it's at a break risk of quantum. With the advancements in quantum computing and the recent quantum computers, we are looking at a 5 to 10 years of timeline where quantum computers can officially forge and crack the private keys of the Ethereum accounts. The second one is native account abstraction. We don't really have an in-protocol way to delegate accounts to some other way, so we can't really abstract the accounts. There were several EIPs like 4337, but it's like an application layer hack, EIP-7702, which is the code delegation, smart contract code delegation, but it has its own restrictions and doesn't unlock the full account abstraction potentials. Gas fees, like someone always has to pay Ethereum. Sponsorship isn't native. So yeah, there are these gaps in Ethereum today. So what do we have? We have Vitalik and the Go Ethereum core developers have proposed a new EIP, which adds a new transaction type. We'll see what's the transaction. It abstracts away validation and gas payments from the transaction, so it can be defined very abstractively. And yeah, we can have post-quantum signatures as part of our cryptographic signatures. What frame transaction? So it's a new transaction type 06. The three words here, validate, authorize, and execute, means the validation is extracted away. It can execute arbitrary EVM code, and it can authorize on behalf of any user. Notice we have a sender field in the transaction specifically here because for the legacy Ethereum transaction, we derive sender from the cryptographic signature. But since account is now abstracted, we would need a specific sender field which would have the address of the sender. A frame transaction is just a bunch of frames within a transaction which can execute arbitrary EVM code. It can verify verification logic and authorize other accounts to execute code on its behalf. We'll see how it can be done in the next. So what's specifically in a frame? A frame, like anything, has a bunch of data. It has a mode, it has a target, the address, which is it's calling to the gas limit. So a gas limit per frame we have, and the data. So basically the code or data you want to send to Ethereum. We have several modes like 0, which is the default one, 1, which is verified, and second is the sender, which acts on your behalf. We can go next. Yeah, so what are these modes? How are they used? 0 is the default one. You can like just, where you don't need to be the sender, you can just use the default mode. It can be used for deployments. It can be used for post operations of smart contract interaction. It can be used for an oracle call where you just need the data and you don't particularly need to be sender of the transaction. Second is the verify. This verify mode is essentially what unlocks post-quantum cryptographic system. You can have your arbitrary logic inside EVM where you define how would you want to verify your signatures. It can be a multi-sig signature, it can be a web auth, it can be a passkey. It unlocks all these different kinds of signatures which will move from ECDSA. And this is the verify mode. And second is the sender, where the account will act as the sender, where you are the transaction sender. We notice we have a special entry point address for all this default and verify mode. It's not decided yet, but it could be a precompiled or not a precompiled. But in verify mode, we only do a read-only validation. We verify signatures. You don't have access to write to the state of Ethereum. You can't modify any data. And the sender is just a normal transaction, how does it work in Ethereum right now? Next slide. Yeah, so essentially how a DeFi can leverage this. This is the whole table where we can interact with a DeFi using a stablecoin as a gas fee instead of Ethereum or the native currency of the chain. So in the first frame, we would have an entry point. So the first frame would be a verify frame, where we would have a signature of the sender. The entry point is the caller and the target is the sender. In the sender address, we would have custom logic for verification. It just means that we are verifying is really the sender of the transaction. Then we would have a sponsor. So let's say I, as a DeFi, want to sponsor a user for interacting with my code base or smart contracts. I, as a sponsor, would like to sponsor his gas fees. So it really reduces the friction of user going to exchange and buying gas fees to interact with a DeFi. As a sponsor, I would have a frame called verify. I would verify that this user is a whitelisted user. Does it really need funds? A bunch of checks a DeFi can do. So how does it want to verify user? So it would be a verify. It would call an approve of code 1, which would mean that it approves this transaction to spend gas on its behalf, on user's behalf. Then as a user, I'll send my stable coin to the sponsor as part of gas fees. So in the third frame, we have a sender and sender mode where we'll just do a transfer ERC20 call. Then in the third frame, so yeah, in the fourth frame, what we have is the normal DeFi execution interaction. We can just call the DeFi or a particular AMM or any of the target contract with the call data we want as a sender mode, because in this, we would have a checks like, I want to do stuff as an account owner. So the mode we have is sender. And the last is just the default mode where the DeFi or an AMM can do post-operation calls, the stuff they want to do after the call. So like logging, housekeeping, bookkeeping, whatever they want. The caller would be, again, the entry point, which is a special address defined in the EIP. Yeah, next. What EIP-8141 makes possible for DeFi is native gas sponsorship. Just as we saw in the last slide, we can have native gas sponsorship. DeFis can truly have users interact with their DeFi in a native way. They can sponsor gas, so users will have less friction. Users will have less friction in interacting with DeFi. They can pay fees in any token. I can pay gas in USDC, USDT, or any other coin I have. We finally move on from multi-step transactions to a single-step transaction. We don't need to do approve and then call the DeFi. We can have atomic multi-step transactions. Yeah, next. So what it unlocks for account abstraction is protocol native smart contracts. So protocol native smart account means we would have arbitrary code in our address, which we can use as and when we want. Algorithmic agnostic authorization, we can have different verification logic for the signature. It could be passkeys, it could be multisig, it could be post-quantum signature, can be anything. And finally, the separation of sender and payer. I could be the transaction sender, but I can have anyone in the world sponsor me for that transaction. So we finally have separation of sender and the payer. So the payer is the payer of the gas fees in this context. And yeah, that's pretty much it. I think that's that. Yeah, thank you.